Now to continue, earlier on we started with the site analysis. Site analysis includes desktop study, site reconnaissance, means you visit the site, and ground investigation, soil investigation. Then we move on to site setup. When you are setting up a site, you need to know what is your level of the ground at your site. If your site area is uneven, irregular terrain, you may want to devise a platform level so that you can have a flat level to work on when you start your project. So you may need to understand how much cut of the soil, how much fill of the soil you need. Once you study sufficiently, you know how much, whether you need to import soil or you have to dispose soil. In Singapore, both operations cost money. To bring soil into your site costs less money than you want to dispose soil. So you need to do leveling. Have you gone through your leveling course? Survey course? In surveying is a process in civil engineering to establish site information, site layout, to do site data. Leveling is the simplest operation in surveying. Leveling means to know what is the level of the ground, to establish the ground of your construction, of your structure, so that you can build them according to the design. There are references, which is called temporary benchmark, TBM. There are also other term used, like the height of collimation. Height of collimation is height of your level instrument. The vertical stand is called a tripod, and you need to mount your automatic level on top. Make it level, and you use an instrument called the staff, so that you can read through the level instrument to see what is the height of collimation, and you do your deduction to find what is the level of that particular point. You want to lay out your site so that you can access it, you can move things in and out. You can allocate spaces for different usage. Spaces include storage, the site office, the rest area, workshop, lay down area, canteen, toilets, security, and other necessary installation on site. Site office, if you're on the site project, that's where you spend most of the time. At least 5 days a week, 8 hours a day. You want to have all the utility that you can have, like power, water, toilet, telecom, car park, access to and from, furniture, lighting, air conditioning. How do you get those? You have to know where you can tap those services from. Site setup in Singapore, security is important. I quote you one example. If you are the occupier of the site and you have set up your boundary, but you have not set it up properly, you have an opening in that hoarding. Someone went into your site through that opening and injured himself or herself. Who is responsible? You are responsible because you are the owner or the occupier of the site, of the area. You have not done your job to secure it, resulting someone else coming into your site, causing injury to himself. You will be responsible. So therefore, securing the site, make sure that you do not allow people coming in freely. And you must know who comes in and who goes out. Very important also, when you start your project, when your project is ongoing, you have material coming in. What is the most expensive material commonly seen in the project site? The most expensive and easily stolen material. Remember this: wire, cables, easily stolen, cost a lot of money to buy, and the material worth a lot of money. Copper in the wire can be sold at a high cost. And if you do not secure a site properly, when you do wiring in your project, be careful. Your copper wire may be stolen anytime. Equipment, delicate equipment, you want to secure it so that it doesn't get stolen, plus it doesn't get damaged. Damaging your equipment or machinery on site will cause you delay, will cause you problem. You may need to do police report, police may need to come in to investigate, you may need to end up stopping your work. Access to and from, and you may need to establish a security system where your workers, supervisors, and project managers may need to carry a pass to be seen by the security guard before you are allowed in. You may need to set up CCTV system to monitor 24 hours 7 to prevent any unauthorized entry. Storage facility for material, for equipment, and also collection of rubbish, collection of food waste, collection of construction debris. Workshop, if you use machinery, you may want to set up a workshop so that you can do repair. Repair including formwork repair, fabrication of reinforcement bars, fabrication of steel sections, fabrication of timber sections. Welfare and sanitary facility. This is important even though it may not sound important. Who are the party that do most of the work in your project? Workers. Workers is one of the biggest contributor in your progress. There's one saying by my senior many years ago. He told me, if you do not take care of your workers, you do not expect the workers to take care of you. So you must take care of the workers because they work for you. You must take care of their safety and health, their welfare, their well-being. Provide shelter, provide necessary sanitary facility, provide water supply, provide rest area. Your equipment and plant necessary for your construction. If you're doing multi-story high, tall building, you may need to know what type of pump you need, what type of crane that you need, what type of vertical transportation, whether you need any temporary lifts, any hoists. Temporary services, you may need to deploy generator to power the tower crane, to power your necessary equipment. And then you also need to know how to move your equipment around. The crane access. You may have heard about accident of crane due to improper access. The access of the road that cannot sustain the load, causing the crane to topple. Once crane topple, it can create a lot of damages to the building, to the facility, to human lives. Then when you do excavation, you need to know what type of soil that you're dealing with, how deep is it when you do surveying, what sort of retaining system, whether you can do open cut, whether you need to install sheet pile, whether you need to do CBP, contiguous bore pile, secant bore pile, diaphragm wall. All this needs to be planned ahead. It needs to be designed. It needs to have specialist contractor to carry out the installation work. You need to understand how it behaves, what are the necessary material you need, what are the sequence of work. One of the excavation, open cut, the simplest one. Then you should ask, since it's simplest, why all the excavations are not done in this way? Some done as open cut, some done as earth retaining structure. Because open cut, you need big space. Imagine you cut 60 degrees out, but your building is only in the center. You need this space in order to do this sort of excavation. If your area is restricted, where you have building next door, you cannot use this method. There's no way you can do open cut. If your soil is soft, there's no way you can do open cut, because as soon as you cut, the soil from top falls down into your excavation. When you hide water table and you cut below the water table, water come into your excavation. You'll be busy pumping out water. Pumping out water in Singapore is only one part of the solution. Second part of the solution is to clean the water before you discharge into the drain. If you discharge the drain, dirty water, again, Singapore being fine city, you will get fined. So a lot of consideration before you choose the method of excavation. Open cut, cheap, good if you have area, if you have less disturbance, less restriction. But don't forget, whatever you excavated out, you need to backfill. So this portion outside of your structure become additional soil that you need to excavate, additional soil that you need to backfill after your structure has been completed. So you need to cater for that in terms of time and cost. Retention system, simplest one is sheet pile. Sheet pile is a piece of metal corrugated in shape that is installed into the ground and forms a vertical restraint You excavate inside the sheet pile cover dam, remove the soil, and these sheet pile will retain the soil outside so that you can create a void in the ground for your basement construction. Installation of these sheet pile can be done using vibro hammer, can be done using silent piler, or can be installed using a vibratory hammer mounted on an excavator. Sheet pile advantage, lightweight as compared to other system. Reusable because it's steel, you can put in, take it out and reinstall in other location. High resistant to driving stresses. Steel has high strength. Can last very long as you keep them in good condition. You can extend the length by simply welding. However, there are disadvantages. You cannot use sheet pile as permanent structure. You must extract it after you have completed your construction. Installation may be very noisy, create a lot of vibration. If you're considering this method in a residential area, you may need to think how you install it without causing disturbance to the surrounding. Because method vibrating it causes a lot of vibration, a lot of noise. You may need to explore other method of installing it. Sheet pile is good when you're installing it in soft soil. Soft soil means SPT less than 40. SPT bigger than 40, i.e. more stiff soil, then sheet pile is not suitable because you cannot dry in deep enough. Worst is you have boulders or rock at high level. Sheet pile, you need to interlock it so that it forms a continuous wall. Sheet pile side by side like this is useless because they are not acting as a continuous face. It needs to be interlocked. It has clutches that comes in different shapes and sizes for you to make interlocking. The most robust retaining system is diaphragm wall. Diaphragm wall is a piece of RC wall in the ground. Construction of diaphragm wall requires you to remove the soil from the ground and cast RC into it to form a wall. And this wall needs to be built panel by panel to form a perimeter enclosure for your basement. Comparing sheet pile wall and diaphragm wall in terms of strength, in a scale of 1 to 10, diaphragm wall is 10. Sheet pile wall is probably in the range of 3 in terms of strength. Costs 1 to 10. Most expensive, diaphragm wall in the 10th place, and sheet pile wall probably 4. That sort of comparison. Time to install it. Sheet pile fast, diaphragm wall very long. Again, in terms of the 1 to 10 scale, diaphragm wall will take 10 months to complete the perimeter of your excavation, but sheet pile will take about 4 months in that sort of range. Diaphragm wall installation, panel by panel, needs to be joined with a stop end. Stop end originally comes in as a tube, as a pipe, where the first panel you cast with a pipe forming an end to that panel, And you will then remove that stop end and cast the next panel against the finished concrete panel. If you use diaphragm wall, the most rigid system, your lateral deflection will be minimum, and you can use diaphragm wall as your permanent structure. It can sustain very deep excavation. The project that I worked on, the Marina Bay Sands, uses 1 meter thick diaphragm wall that enables the excavation. The deepest part of Marina Bay Sands was 26 meters from the ground level. That is the basement 5 car park. Contiguous bore pile is another type of retaining system. It's formed by having bore pile installed with a space of about 100 mm between them. This is how it looks like after it has been completed and exposed, where you excavate inside, and this contiguous bore pile forms the vertical retaining system. Contiguous bore pile has one gap of 100 mm. You can see there's a gap in between the bore piles. And this gap may need to be sealed, depending on the soil. If there is water seepage, you may need to seal those gaps. And always using this system, whether it's contiguous bore pile or secant bore pile, you need to construct a capping beam to tie all the piles together. Secant bore pile that interlocks with each other. This soft pile constructed first, then you cut into it to form the hard pile. And it forms a continuous 4 piles line to have a retaining system. Compared to contiguous bore pile, they are individual piles, not interlocked, versus secant bore pile interlocking with each other. Once you know and deploy your retaining system, which is the vertical face to retain the soil outside while you excavate inside, now you need to decide how to excavate the soil and construct the structure. 2 ways. One is bottom up, where you remove the soil all the way down and build up from there. That's called bottom up. There's another technique called top down, where you cast your level 1 structure, slab, and you excavate down and cast your B1 structure, excavate down and cast your subsequent basement structure. And this will also enable you to construct upward simultaneously at the same time as you excavate down. Bottom up requires you to excavate all the way down and construct bottom up. Top down is 2 ways, up and down at the same time. For bottom up is easy, simplest, less steps to be worried about. Design also simpler, but it's limited to one direction construction. Time needs to be allowed for longer duration, and a top down like this that you can construct downward and upward at the same time requires complex planning, complex design. Requires king posts. King posts are your temporary column. Therefore, your sequence, your costs, your budget, and your time allocation needs to be studied in detail. So far, any questions from anyone? We've come to the time almost with is left, I would like to do a recap. And this is where we're going to stop for today. But a quick recap now.